Hello, this is Automat live coding, and today we are going to implement a filter for our instruction deck that would allow us to select input and output registers. If you see right now, every instruction that we have, they all seem to use the default registers, like EAX. In our design, it looks slightly differently. Let's take a look at this. So here we should have a table, and on top of each table column we will have the symbol for a register. On the left there will be this is an older design. Let me find the newer. We will have those two elements, eyes and a hand with a flag, and within the categories, within cells of the table, we are just going to display numbers. If a cell is selected, we will somehow highlight it, and we will show this how many instructions are selected right now, and how many would be selected if we deselect this cell. And don't pay attention to this. We also will have a restricted set of registers. So we'll have 2, 3, 4, 5, 6, 7, I think those 8 registers only. Yeah. No extended registers. Even though they are fun, for simplicity we will start like that. The reason is that I would like to hide extra functionality of the assembler behind booster packs. Like booster packs, they're not going to be paid or anything like that. They are just going to be a mechanism to avoid unnecessary complexity in this user interface. So it will be fairly small, fairly simple, but if you want to access some advanced features like, I don't know, VM manipulation, because maybe you want to run virtual machines or whatever, then those extra categories of instructions will show up, and extra registers will also appear only then. So things like MMX or like SSE register, they are called XMM or YMM or ZMM, or the most recent ones are called TMM, and they are larger and larger, and they allow processing of multiple data elements at the same time. We're not going to show them right away. We'll just show this, and we will put some booster packs somewhere. Maybe there will be a category with booster packs. So there is that. Yeah, there is a lot of things we would like to have, but let's take it a bite at a time. So the plan for today is to do this. We want to have buttons for register filters and the ability to pull out an instruction. This is also super important. Okay, I think we will start with this button for register filters. It's probably I mean, both are necessary for this whole thing to work. Like, almost everything is optional here, but those things are necessary. We need to finish them. Okay, so here I have our draw function. This is the function that renders the instruction library, this whole widget. And like we do it in the design, we'll draw around the rectangle below the instruction selector, instruction library. So here we will draw let's call this a register table. We'll have 8 registers. This will be EAX, A, B, C, D. And then there is source index and destination index, base pointer and stack pointer. Maybe we could hide the stack pointer. I'm not sure if it's a good idea to have it even here. So the way we operate, it's actually fine if stack pointer is overridden. It's not an issue. Okay, so maybe we'll just go with 6 instructions. 6 registers. Anyway. Okay, so I think register is probably a bad name. So I want a struct that would contain the, I don't need the name of the register, but the data that we need to render this register. So this is like display information about a register. Terrible name, but I cannot think of a better one. Okay, our persistent image cannot be constexp because I think it has a constructor. Exactly. Okay, for now I will comment this. We need to prepare the images, right? We need them. Oh, where did I have them? Not here, not here, here. Yeah, there was a new update to Krita Stable Diffusion, Krita AI Diffusion. My favorite plugin to Krita. Okay, so we need AX. It looks awful. We should regenerate this. Okay, let's try saving with terrible quality. Plain quality 50%. And let's see how this looks. Ouch. Let's scale the image. Okay, so the size fell down, resolution as well. The colors are so washed down here. Icon, that's an interesting preset. I think icon is meant for different type of images. Make it smaller. So actually the image will be shown at a very small scale, something like that. I think it's acceptable, 40 kilobytes is acceptable. Okay, so let's do this for all registers. I think exposing BP and SP would create more issues than it would solve. So we will stick to just 6 registers for now. Exposing stack makes assembler much more complicated because you have to think about something kind of external that you cannot directly see. You would have to visualize stack for this to work nicely. And this is tricky, so many things can go wrong there. It's absolutely possible, but it's pretty hard. Okay, and I will build this so that we embed static files. By the way, how much size did we contribute just now? $300 kilobytes. A lot. But I guess it's necessary. So those are all you see there is quite a lot of registers in here. A lot of them are aliases, so one of them is, okay, maybe not those. Anyway, I thought a single register will identify a whole family of registers that use the same kind of capacitors in the CPU. But it seems we have slightly different. EAX seems to be different from AX, which seems to be different from AL and AH. Oh well. I think we can figure this out with reginfo. Next is not going to be BP. Okay, and this is slightly strange. We have this ESI. I want to see how it's described in LLVM code. So we have RDI and the RSI. Okay, so there should be SI. A register. Okay, and there is SI register. But actually, thinking about this, we can use R, like the extended version of all of the registers. If the instruction will require a shorter register, we will pick a shorter. Okay, this is enough. 6 registers should be enough for everybody. This is very convenient. So this is a function that allows us to build a rectangle using those two parameters, and the size of the table. So the size of the cell I am picking so that this is the smallest thing that can be reliably pressed with a finger. Let's use HTML naming. We will use 2 rows. So I will close without saving. we'll just add the appropriate offset here. Okay, so it has to start here maybe. And now let's pick a paint. I think this should be the same color that we use for cards. That was E4, E4, E4. See how this looks. Now it's not perfect because we are placing the center of the table here. I always wanted to have so see, we have a ton of functions here that access specific parts of the rectangle. And I think it would be nice if we had something like this, make anchored. I think we could use those functions here as template parameters here. Okay, so what we will do, we will I will initialize this like that. And then I will grab the default anchor position. Okay, this is pretty cool. What do you mean there is no bottom left corner? This is irrelevant bug. It's starting to annoy me. I will have to look at that and try to fix it. Oh yeah, it has to be a type, it can't be a function. I could even make it, like, I could even put it here. Maybe if I rename this struct. Nice, it kind of works. We have 8 values here. I'm thinking maybe we could have 3 and 3. I don't like that it's such a long invocation. It should be much smaller. So I could move them out of this class. Now the issue is they are still undefined, but maybe I can do it here. Because it's a template, it's going to be instantiated when it's invoked. Means I don't need those. Looks much nicer. Now I could also remove the names here. Okay, it seems to work. And instead of make, maybe I could turn it into a regular constructor. Unfortunately, we already have something like that. But is this used? Okay, I think I will change this. so that this is explicit, and we can remove this constructor. And to simplify this, I think I could remove this anchor position from here. That should still build. I want to convert this into a constructor now, because I think this is a very nice, very generic way to build a rectangle. This move by, it's weird, it's like working in the opposite direction. Oh yeah, we need to add a negative number, that's fine. Okay, the final change is to switch this. unfortunate. Okay. In our design, the icons are fairly large, but I think we only need to offset them by the height of a single cell. So margin top, I will subtract one cell size from this. Okay, now it looks slightly nicer. Let's draw the lines now. And this whole table, I will hide this inside the block, so that it's easier to, so that it's harder to leak variables, because some of them have fairly generic names. I don't want them to leak outside. Okay, we will use the same paint. Start with the horizontal line. Draw line. Cool. Cool. That should probably be slightly smaller. Let's start with one. Okay, now we have a table. Fairly simple one. So maybe now above the table we will draw the images. pretty nice. So the thing is, I think the alignment could be better. So this should put them in the center. Yeah, actually they look pretty nice already. We could make them larger. $11mm. I think this looks good. Oh, maybe they could be even larger. Let's try 12. Because at the default zoom level they are hard to distinguish. And it's okay if they overlap. The point is not to have something perfect. No, I think the size feels better. Yeah, if I make them larger, the circles is going to obscure others. But I will move them 1mm up.
Marek Kowalski says,
Hey Merritt, great stuff you're making. I wonder what's your opinion on print debugging?
Hey. Yeah, I love it. I use it all the time. So to be honest, I use both kinds of debugging. If you have a debugger configured, then things like segmentation faults are nicer to fix in a proper debugger. For instance, I have an issue here when I select some of the instructions, like those jump if or this one, I don't know what it is. It crashes Automat. And debugging this with printf would be hell. But I can try to debug this with a regular debugger, and it's like stuff like segmentation faults in particular are super nice to debug. Okay, I was playing with VS Code config, and I guess now it's unable to build some things. So most of the time I actually use printf debugging, but sometimes debugger is just nicer. Printf really has this property that it's almost like having a graph, like through time, of the execution of your program. You print some variable to the console, and if you like look at it like vertically, you can like see how this value is changing. It's very convenient. It's like having the ability to plot and it's so easy to invoke. So what's the issue here now? What is going on here?
Yeah, I love it too. My colleagues at work think I'm mad. I can't imagine debugging code with multiple threads, which are time sensitive.
Oh yeah, for multi-threading. So actually whenever I use a debugger, it pauses all the threads for me. So, and I kind of use this. I just often take a peek at a list of threads and where they are stopped, but all the time they are just stopped in some kind of mutex or some kind of pause function. There is usually just one thread that I'm interested in. But for multi-threading, yeah, having those logs where you have an aggregated view of everything that happens in multiple threads, serialized. It's convenient. Nah. I wouldn't worry about what people at work think. Programmers tend to be very rigid in terms of their habits. So the best approach is to use the best tool for the job, and sometimes it's printf. This is the right ethics, engineering ethics. If there was something like that, it's use the best tool for the job. And in engineering, there is no place for dogmas or this kind of dogmatic thinking that you always should do this or you never should do that. It's always trade-offs. And in the end, the cost matters, right? Whatever is cheaper or faster to execute. At my, I think, bachelor's exam, I even had this question. So the professors were examining people and they asked you, depending on the topic of your thesis, they picked something and they asked you, hey, do you think A is better or B? They asked you to compare two options. And the wrong answer was to pick either one of those options, because almost never, the situation is almost never clear. Usually you have one option which has some trade-offs. It works better in some conditions and worse in other conditions. Yeah, and this is what they were using for scoring. So if you said, oh, A is better, A should be preferred, you would literally get negative points for this.
PP Chica says,
I usually do just a templated struct with TTS-ed for logging since I can wrap it const expert all day.
I have to run somebody's at the door. Be right back. Oh yeah, Captain Chica, your approach is identical to my approach, by the way, for logging. Although, okay, I don't use const expr.
Mark Kowalski says.
Exactly. Use the tool for the job. Nothing is perfect.
Yeah. So this is how I use the log entries. But what you just mentioned about templating this. So what does it give you templating this struct? Like, it's convenient because in
CP Chica says.
Links allowed so you can see the code.
I'm not sure what you mean, trying to understand this. Yeah, so I do the actual logging in the destructor, and this struct is used as a buffer for aggregating the log line, and it's using external string as a buffer to do this aggregation. I mean, not external, internal string, but std string, so it's allocated. Oh, yeah.
Can I send a link to the paste bin of the code snippet?
Yeah, and they work. We don't get that much spam, so I enabled links. Still compiling. I should set up CC cache or C cache, because I think I've built it so many times already. Okay, that took a while, but we've built the debug version of Automat. I have to rebuild it because I changed some things. It's constantly compiling. Compilation finishes. By the time it finishes, I have to rebuild it again. Okay, I wanted to play with the debugger.
Marek Kowalski says,
Another downside of normal debugging. It's slower.
Yeah. Couldn't create a main window. Okay, this never happened literally. Oh yeah, I know why. I need to set up proper display variable. Cool. So this is the line that's failing, but... So the nice thing about debugger is that if you have like a complex struct with lots of pointers, you have to like follow a long chain of this kind of stuff, and you actually don't know what's relevant. It's easy to do this in this like interactive variable explorator or in the debug console. How do I change those configurations? So something changed on my PC and now I need to use display :1. I have no idea why. So this kind of stuff is super nice because I can go up the call stack and see which instruction is causing the issues. mcinst opcode 406. EBS FP80. Oh yeah, actually this is a good thing to know. We shouldn't print all of the instructions, only the instructions which are part of some group. Okay, we don't need to do that. Okay, I'm thinking about doing something about our previous discussion about using the best tool for the job. I'm about to use something which is considered like the worst thing. Or maybe I don't have to. Maybe I can use lambdas. I wanted to use gotos. Another debug attempt. I think we can get rid of those now, because this filtering is now done in Python before we even, during compilation. Okay, and there it is. Okay, some of our operands needs an immediate. Oh yeah, I wanted to actually see how to configure conditional opcodes in LLVM. So if I see correctly, okay, those are just synonyms. So greater is the synonym for not less equal. Greater equal is a synonym for not less. So for each of those, I basically need to add the right immediate to the opcode that I'm printing, to the instruction. It's nice. Okay, so this is the situation where we are right now. So some operands have different types. Let's try again. I need to put some instruction here. Now we can take a look at operand. Okay, so this is a good example where debuggers are nice. I mean, sometimes they are nice. This is the situation where they are nice. I can like inspect the variable and see exactly what it's doing. Operand type is set to... This is 15, right? Okay, so this is target specific operand, I guess. Nice if I could bookmark a directory, because there are so many of them and most of them are totally uninteresting. Okay. I will try to take a look at this. This is third-party LVM here. Like this is the file. Oh, actually no, this is it. This is the condition code. Music seems broken. How? I guess my PC is crashing. Oh yeah, I probably need to stop debugging. This is fun. Yeah, VLC on Linux sometimes has issues with debugging. So when debugging is running, VLC sometimes just stops working. It's probably some Linux kernel issue. Maybe it's using ptrace or whatever. Okay, so I need to include this file. x86 operand count code. Cool.
See, Pichika just followed on Twitch.
Hey, thanks for the follow. stuff that we are doing here is actually super... Oh no, I lost the place where the crash was happening. So here I should do this add immediate, but I don't know what immediate to add, because LLVM uses some quirky encoding. So each instruction in the x86 can have a bunch of conditions which are checking some specific flags in the flags register. Like less is a condition code which checks, I don't know, probably carry flag or like sign flag and overflow flag. Greater checks, I think, carry flag. And yeah, equal checks 0 flag, and so on. I don't remember the details of which condition checks which flag, but this encoding of numbers to specific condition is something that we will need. The crazy thing is that it seems that this operand count code isn't used anywhere. Very, very strange. Oh, okay. So apparently we have this. So the file that I am in right now is probably one of my favorite components of LLVM. It's totally useless to me or to almost everybody, but I like the code which is here. Like whenever I want to find an example of how to use some part of LLVM, this LLVM exegesis has it. It's exercising almost every part of LLVM assembler, which is kind of what we want to do as well. And here it's assigning random condition codes. I also want to see what it's doing in this line. Okay, nice. There is an enum within x86 namespace with condition codes. And this is what I needed. Cool. Those are probably some optimizations. Those are some lookup tables for optimizations. Uninteresting. I just want to go through those. So this is overflow, not overflow. Below, above equal, equal, not equal, below equal, above. Sign, which is like negative. Non-sign, which is positive. This is parity, less. I don't see 0. Maybe equal and not non-equal, yeah. Those are 0 and non-zero. Okay, an assertion so that in debug mode it would crash. In release mode it will do nothing. Yeah, and this was a digression, this thing here. We don't really need this immediately. I just wanted to play with debugger a little bit since we were talking about it. The nice thing is that now we can, I think, yep, check those instructions. So loop instructions are slightly different. They don't have the proper condition code. They are very old. They have just hard-coded some like free variants of loops. So they don't really take condition code argument, but jumps do. So JNE0, JNE0, JNE0. So those are free jumps. This is 1 bit probably, 1 byte, 2 byte and 4 byte jump, I'm guessing. And this is a jump which will jump if the CX register is set to 0, okay. Pseudo instructions, I think we should remove them. Okay. Let's go back to our selector. because we can now properly display stuff. Yay. So we need to put some icons here. Let's load those icons first. Should be there. Maybe I used the wrong file name. Nope. That looks very nice. Oh yeah, we are drawing this below the cards. I think the size is alright, we just need to center them properly. can combine all those translates into a single one. Okay, now they are center aligned, but I think they are too large. It shouldn't extend like that. I think it's okay. Next step is I would like here to print the number of instructions that will be in the deck when I click this button. Like each button should display its result, what will happen when you click it. Okay, I'll make a short break and soon I'll be back. Okay, so I have some food to eat, but in the meantime, there is a recording from a recent demos that have happened in the Future of Coding community. So I will mute myself and we can watch some nice demos.
There we go. Great. Welcome, everybody, to the first Future of Coding meetup of 2025. If this is your first time here, I'll just very quickly explain the format and then we'll get into demos. We've got demos today from John Christensen, Andrew Blinn, and Christopher Schenk. So 3 demos. It'll take us about an hour. And the way that we run these meetups is we have a chess clock with 2 sides. We give 7.5 minutes to the presenter and 7.5 minutes to the audience. So you get some guaranteed time for questions and some guaranteed time to present. And if at any point during a presentation, you in the audience, you want to ask a question, just be rude, barge in, ask it. I'll flip the timer over to audience time. And then, once the question is answered, we'll flip it back to presenter time. And I'll just kind of handle that behind the scenes. I'll try and give like a 1-minute warning when we get down to the wire. Presenters, since this is such a tight window of time, 7.5 minutes goes by really fast. It's very helpful if you spend the first 30 seconds to a minute really clearly laying out, like, here's what I'm building, here's who it's for, here's the, level of polish, it's just a shower thought. It's something I've been working on for my whole life. And you, just kind of share that little bit of context at the beginning, and that's going to help us understand everything to follow. I think that's all the protocol we usually go with. So on that note, John, take it away.
All right, great. Hello, everyone. I'm John Christensen, and I've been spending about the last year working on a little graphical programming environment for scientific computing. So to give some background on what this is all about, my research lab that I'm a part of, we do MRI physics at the University of Wisconsin. And what we're looking to do, and kind of why I was hired as a software developer in a physics lab, which is a little bit not super normal. That's not none of the other labs.
Hey, everyone!
In the medical physics or radiology departments that are adjacent to us kind of have a software developer like just in a lab for a single lab building like end user facing software. So it's a little bit unique, but I really like it. It's a really interesting area to be in. So what we're working on doing from a basic science perspective is we are trying to do MRI image reconstruction. So you have an MRI scanner, it's collecting a bunch of data, and that data is nonsensical when it first comes off of the coils that you're reading, current that's being induced, and we need to be able to process that. So there's a variety of different techniques, and it's a very active area of research of how you do this reconstruction and how that plays into how you're going to run the MRI machine. So there's a complex interplay here between how you're running the scanner, how you're collecting data, and how you reconstruct an image from that. And so we do all sorts of different ways of collecting this data, and that influences how the image is reconstructed, and it influences how good of an image you get out and what are the different trade-offs you get. So like how sensitive are you to if the patient moves in the machine, or all these different factors. And so this research group about 10 years ago had created kind of a homegrown solution of how to be able to design these things in a little bit more user-friendly way than just doing everything in just raw Python scripts or MATLAB scripts, because basically people wanted to have a more direct connection with being able to move a slider to change a value rather than changing a value in source text, hitting run, seeing how it changes. That's not quite right, or changing a value again. So that was very frustrating. And so they didn't like it enough that they spun up a whole little node and wire editor using Qt through Python to kind of handle all these problems. That kind of got older and older over the years, and the people that originally had made it were, PhD students that had, gone off and done other things, so they weren't really around to, keep maintaining this. So the software kind of got older over time, got buggy. No one really knew how to fix it, and eventually kind of has started to be at the brink of death. But about a year ago, our PI hired me to resurrect this software, to make a new version that hopefully is a little bit more robust and has like somebody full-time working on it rather than being like a kind of side thing that PhD students are doing in addition to getting a PhD. And so what my goal here is to be able to make some sort of graphical programming environment that lets scientists easily compose networks of functions. And these functions are more high level. We're not talking like a low level, like having an if statement for one of the nodes that does a explicit add or multiply. We're thinking more having bundles that are doing entire pieces of algorithms and then composing those blocks together, which I think is a lot more achievable of a goal than replace everything with graphical, at least in the something that I could feasibly create in a reasonable amount of time. And we really want to be able to do this so that we can have really nice, easy ways to change data around and see
I'm
what's
gonna interrupt here and take advantage of the format for two reasons. One, because I have a question, and two, just as a sort of you've got 3 minutes left in your time. Goes by fast. So my question is basically, if you're rebuilding, and maybe you'll get to this. If so, I'll burn a bit of audience time on you covering this part of the presentation. But I'm curious how much of this is about designing the interface around a known set of composable functions that makes sense for this domain, versus how much of it is actually designing those functions and figuring out what the building blocks ought to be.
Yeah, I think that's a great question. I think I'm kind of somewhere in between, because we do have a good idea of what the high level like algorithms are already going to look like, and there's already we already have all of these Python functions split out, but there's definitely a lot of room for building some things that are a little bit more generally like more fundamental building blocks to have that are more composable. There's some cases where it's just like, when you're laser focused on solving one problem, you kind of just start throwing lots of things into one box. And I think there's more room to break out some things, maybe merge some things, and kind of change what the fundamental building blocks are. So that's going to be kind of a very active area of design work going forward. Yeah, and then just one more thing before we jump into the demo is the things that I'm looking to improve on the existing, what they had already had, is kind of make something that's more stable, more usable, that just has more, nice UI features, because that's not necessarily something that scientists tend to focus on when they're developing software, and make things that's a little bit more reproducible by having a more explicit, form of saying like, these are what the Python dependencies are, so that when you share it with somebody else, they can actually run it without needing to go through lots of trial and error, and just making things a little bit faster, because there's just some areas that can be a little bit quicker and have less latency than what they currently have. So this is what the tool looks like today. It's pretty it's not super fleshed out, but in this case, what we see here, this load image is just a Python function that loads an image and outputs a NumPy array. But we can start chaining things together. So one thing so this image here, this is a test brain that is commonly used just to kind of highlight, just to show what it looks like when you do different image manipulation operations to it. So we can take a Fourier transform of our image, and the UI is still a little clunky. But once you wire everything up, you can see like, okay, that's what the frequency components of this image look like. It's not really super sensical, like what it looks like. But one thing we can do here is we can see like what happens if we manipulate data in this space and then convert it back. So maybe I'd want to make a mask that is like a circle. So I wrote a little function to create a circle mask. It takes a parameter that's just a radius. I'd like that to be more discoverable in the UI to actually be more clear what's going on. But right now there's not really much other than I need to know how it works. And we can look what this outputs by plotting it. So if we change the slider, we can, change the size of our mask. And now we want to multiply our mask times our Fourier transform image. So I'll just have a really nicely named 2D underscore multiply because I made this like yesterday. And we can look at what the output of that looks like. I don't know how well it will come across on video compression, but you can see we've kind of blacked out all the regions outside of our mask. And then finally, we'll Fourier transform this back into the real world.
A Fourier transform or an Fourier transform?
Great catch. We don't want to do that. We want to inverse Fourier transform, so we actually end up back in the real world. Okay, so now what we can see is when we have a mask that's really big, we get basically the same image that we started with. But as it comes down, what we're doing is we're cutting out all the high frequency components of the image. So any of the fine details get kind of washed away, and if we go smaller and smaller, we're left with just the really low frequency blob that was originally there. But kind of the cool thing here is that we can really quickly explore that whole space of all the different possible radiuses of this without having to change a number in source code. So that's really the thing I'm happiest with how's this going.
Tom has a question. Tom,
yes,
go ahead.
Tom.
Not really a question, but like a kind of suggestion. I worked in one of these like neuroimaging fields before, and this was like way back in 2012. And I wrote this piece of software, and it's probably the most popular software I think has been replicated more times. And it was for ImageJ, but that's like irrelevant. And what the scientists, they kept having to label these images. And the tool I wrote was a brush that allowed you to brush the region of interest, right? So you have interactivity on the parameter space, but then adding as far as I can see, there's no interactivity on the like actual spatial, image space.
Mm-hmm.
And I don't know if you have a use case for that, but like it was very popular, that thing. It was insane.
Yeah, I think that's an interesting like specific use case. In my lab, we don't specifically annotate on data in that way, but it's definitely something that would be interesting to do. I think it kind of brings up an interesting point of what parts of the tools can be extended by the users. So like a big focus of this is that, I want users to be able to build whatever they need by, creating new nodes, and having some way of specifying simple UI. Like on the left here, the plan is that this would all be kind of configurable for parameters of a given node of these kind of inputs from Python. So some sort of simple like layout that you can specify. That gets much harder the more complex the UI you want to go. Like I don't know if I want to open the door to like, could you make something you paint over from Python? Like I don't know if you want to open that bottle, But yeah, I think it's interesting to think about where you want to put more effort into, like, okay, I'm going to create some specific bespoke UI components that are more hard coded, and then what is the set of tools for, you know, more general UI components that will be simple for, you know, non like professional developers, or yeah, what would they would be more able to work on as a scientist that's not as concerned about creating fancy UIs.
Jasmine, you've got your hand up, and we've got about enough time for probably just this question, and then we'll wrap.
Great. Yeah, thank you for sharing this work. It's always interesting to see what the neuroimaging folks are thinking about. I'm thinking the theme here is that the widget toolkit is what's striking to me about the widgets. They look like I've seen these kinds of nodes in Jupyter, right, from the Blueberg IPy widgets project. And what Tom just brought in was more of a layer that requires bidirectional communication with the node and not just with the widget panel. And you're suggesting, okay, maybe that's, if I understand what you're saying, that kind of component is too advanced for the end user themselves to design, but we're interested in what they're able to configure. And we're trying to get to a point, I guess, what do you see as the boost? Where do you see your efforts as a developer being split between creating new types of components and just making the environment more stable here? Where do you see that balance shifting as the project matures in some way?
Yeah, I think definitely right now my head is in, I want to get a minimal working thing that my lab mates can actually use to get their work done, and focus on like getting the basics done, and not, you know, opening, you know, too many doors to things that are really cool, but could potentially lead me down rabbit holes that'll just kind of be really difficult to solve as like a single person developing a big piece of
Oh
software.
yeah, and what's the
I'm like
impact?
trying to like not bite off any more that I can chew, finish that, and then, you know, once that's working, then have enough kind of time and freedom to be like, okay, if how can I explore around with this and see, you know, what I might be able to do without becoming too complex. But right now it's like, yeah, I want to keep things simple.
Thank you.
Yeah.
I'll just
do you want to 30 seconds wrap up? Yeah.
Yeah, just end with saying I really have enjoyed making something with like Node and Wire. It's like, you know, pretty basic. I'm not doing anything revolutionary here, but like it works well and it's simple and people can figure out how to use it pretty easily, especially if they already know kind of the domain that the tool is around. And so, yeah, I think it's great. I think there could be more Node and Wire things out there. I think it's easy to implement and a good solution that doesn't require you to like reinvent a whole field. I'm gonna maybe have, you know, occasional updates I would post on Mastodon. I have no guarantees on how often that will be, because it's, yeah, I probably could share more scrappy fiddles, as some people say. And so yeah, I'll be doing that. But thank you all for your time. Thanks for all your questions and feedback.
Super cool, John.
Yeah, nice environment. It really shows that this UI, like design paradigm, is actually rather fast to implement and rather cheap. He's doing everything from scratch, if I understand correctly. So he's probably not using any Node and Wire library. He could also go for a library, but I guess in his, like he says, it's probably not such a big cost. He can like design this whole environment himself. And it also makes it easier to manage. I imagine in a medical facility, you cannot really install arbitrary random dependencies from the internet. It's nice. In this sense, it's very nice that it's self-contained. Yeah, a lot of the things that I think could be part of this environment there is this library called Gegl, G-E-G-L, generic graphics library. This is part of GIMP, and it's a stream-based image processing library, which is very nicely optimized. It contains optimized primitives for like everything that GIMP does. And it naturally follows this stream-based. It is stream-based, essentially. You construct a graph. Yeah, it's a data flow-based image processing framework. So it's similar to GStreamer, similar to FFmpeg, all of those. So I think if... I know he's also processing 3D images, so I don't know if Gegl will apply to 3D data, but could be useful. For arbitrarily sized data, there is also TensorFlow, which is another data flow library for, this time not only for images, but for like multi-dimensional data. And the big feature is that you can also run it backwards. So if you run some data, you can also say, hey, I want as a result get this, and it will adjust the graph for you so that the output is what you want it to be. Very fun thing. Obviously it's used for neural networks. Like this is the origin of this library, but it's not necessarily only for neural networks. It also can be for, I don't know, like adjusting colors, or it's just backwards. It's just a differentiation library that can also compute forwards and backwards. Yeah, cool project.
John, thank you very much. I do love a node wire interface. Andrew. I'm going to reset the clock. 7.5 seconds, 7.5 seconds. Great.
Yes. All right. Can you see my screen?
Yeah, we can.
All right. I'm not going to spend that much time contextualizing this because I just blab on forever. And also, I guess, similar to John, I'm like a PhD.
Okay, I think I heard about Hazel. Hazel it looks amazing. It's like a structural editor. It's very polished. I've seen some images. It's nice to finally see a proper presentation from the author.
Student, this is like a side quest on a side quest, so like not necessarily related to my main research, but I'll hopefully loop back at some point. I guess the general topic is graphical user interfaces embedded in program syntax, which you all have probably seen before in one form or another, including perhaps Livelets in Hazel itself. Also, Leif Anderson has done some incredible work in this space, and Racket and Clojure.
Give me a minute. Andrew Blin, is he on YouTube? Maybe he did some videos on... Yeah, he did present it on Strangeloop. This is where I must have seen this.
Also, yeah, CodeMirror has this really nice decorations architecture to this kind of thing. You might have seen this before in Strudel, but like the basics here is like, so if I have, say, a Boolean literal here in the Hazel editor, I can click this toggle to turn it into a checkbox, and I can interact with it as a checkbox. So the way Hazel works is what we call a live program sketching environment. So you can see the program evaluated down here as I check that checkbox on and off there, and I can interleave this with just regular program text. I can create another Boolean literal here, and I mean that'll always evaluate to false, but then I can turn that one into a checkbox as well, and if I turn them both to true, then that's true. We're not limited to checkboxes. I can also create sliders. Here's an integer slider. I can manipulate that as expected. And I can also create text boxes. So if I have a string, I can turn that into a text box here. And this is like multi-line. So if I create another line here, you see like that string has a line break in it, so it's like a little bit friendlier way of interacting with the string. I can turn it back into text.
This is amazing.
Perhaps not as pleasant a way of working.
So one thing that this shows very clearly is that people often divide like visual programming on one side and textual programming on the other side. And Hazel, it really clearly shows that it's not binary, it's more of a spectrum. You can really pick any point between them, and this is what you want to build. And so you can have like textual programming language with some graphical features, like widgets. Or I imagine graphs. Graphs would be super useful to have inline in programming. Imagine debugging if we had graphs. If I could like dump stuff to a graph here, run my application, doing whatever, and I could see, for example, over time, like some value is changing. That would be insane.
With multi-line strings like this, but I can do this if I want. I can create another line and then turn that back into a text box. So
I'm jumping in with a question right here, right off the bat. Have you fixed regex? Like, you fixed booleans, you fixed numbers and strings.
Yeah, by the way, this is a very good idea, fixing regex, because regex can be visualized nicely. There are some regular expression visualizers. I don't know. Let me grab some regex. Right, so this thing, which is totally unreadable to somebody who doesn't know regular expressions, here it suddenly is readable. So you can see like value from one of those 5 kind of categories, then a dash, then one of those 2, then .tar, then some extension. So you can clearly see at a glance the structure of how regular expression, how this works. And this representation, this visual representation is actually closer to what regular expression actually is. It's not exactly, like after you compile a regular expression, it looks slightly differently. It has many more kind of internal nodes, but it's one step closer to the how regex actually looks in computer. So I think Ivan is referring to like making this a reality. So this is a unidirectional, this is like a view into a regex, but this could very well be like user interface for building regular expressions.
Regex, because I think it's the most broken of all.
Not myself, but I have seen some really cool UIs for regex that I think would be a great fit for this framework. I mean, like there's, railroad diagram style ones, et cetera, et cetera.
Yeah.
But yeah, I mean, like it's.
And this is a railroad diagram.
With this, although I must emphasize this is a side quest emphasis, is on creating a very nice API for embedding these things. So yeah, I mean, I'm not going to have that much time myself to work on specifics here. Although my next example, which is the one that got me invited to do this, will be a little bit of a different kind of fun one that I did over the break. But yeah, like I it's like when you see this kind of stuff, people will often do checkboxes and sliders. Color pickers are a classic, and yeah, I think it's probably time for regex to have its heyday as a canonical example. Not quite yet, unfortunately, though.
Okay.
But yeah, so I mean, I just showed you there. I have these different kind of projective interfaces for the base types. In Hazel, and I mean, like if you go to the Hazel webpage now, you can actually look. There's this documentation slide up on projectors that kind of details. Oh yeah, I forgot about this one. I had this code folding one here, so I've folded up this definition, but I can unfold it to see what's inside. Oh, there's another one. I can double click to unfold this thing too. Oh, and yeah, there's some text inside. I can fold it back up. but yeah, you know, it's my emphasis here, maybe more than some other similar architectures, was making these things kind of like polished and fun to play with. Like they behave well with selections, etc. Like you see, like part of my API here was like it's this text area has its own kind of custom selection effect, and that's all specifiable in the API. Oh yeah, but like other than these things that just replace literals, there's a couple other ones that I did for kind of like, I don't know, debugging purposes. Like there's this type inspection one here where like if
I've got a question. I've got a
go ahead.
question. I'm super interested in how you do this selection. Like what is the sort of model that makes that possible? Is there any tech involved here?
I mean, not like I'm just talking about like the graphical aspect to it, I guess. Like token decorations have like a default, or like just text tokens have a default kind of decoration, like SVG drawing thing, and then yeah, you can override it for these what I call projectors here. I mean, are you talking about the selection shapes, or I guess what specific aspect were you interested in?
Well, I mean, there's all kinds of like weird problems. Like if you're doing it on the web, it's like how do you get the DOM to actually like, you know, not accidentally highlight something random miles away, or just getting it to plain like is it the native selection, or is this like a completely
No, this is like completely custom in ways that probably aren't wise, but yeah, it's a lot of sweat and elbow grease re-implementing the wheel basically.
Yeah.
But
So even though it's completely different, I think, so he's mentioned that this is based on like tokens and token decorations, so I think there is some underlying like string-like representation. So it's probably still possible to do like a sync with HTML selection. And I think HTML may even allow multiple selections. I don't remember. I would have to check the API. But yeah, even if it's like totally separate, it only needs a mapping between the two types of selection and it can interoperate.
But I'm trying to do it so that other people won't need to do that. Like if you want to implement a custom projector in our framework, yeah, I've done the heavy lifting. Maybe I shouldn't have done it to begin with, but at least the next generation will be spared, perhaps. But anyway, so just briefly here, yeah. So I can put this type projector on an expression, and it'll show me what the type of that expression is. Not particularly useful here because there's a annotation right here. But you know, if type inference is going on, that can be potentially helpful. There's also this value probe thing. So if I go to probe down here, I can see an inline evaluation of 1 + 1, which I probably could have evaluated myself, but nonetheless, it's 2. Anyway, over the break, I did a kind of a just purely for fun example that kind of took off on social media. And that's this playing card literal. So I've defined this algebraic data type here to represent playing cards, and a card is a pair of a suit and a rank. And if I click on this literal here representing the spade, the jack of spades, I can convert that to a card, and I get this little card inline here. And you see this card takes up 2 lines, so it's kind enough to like, I've got a layout system that realizes that and creates an extra line for me here. I can do a little bit with cards. I can click to flip them over. This is purely an aesthetic thing. It's got a fun flip animation. I don't know whether that comes through at the zoom frame rate.
I find it very interesting that we are both working on cards in programming. So our cards are here, but you can also have cards like that, mixed with text.
But also I can shift click on the card and pick another kind of card. I'm going to turn that into an ace of diamonds. And yeah, I was kind of motivated to do this.
By the way, this is also a nice interface. It's very tiny. I think it would be very difficult to actually use this. I want to also target fingers, so finger input. So there is like a minimal size of the touchable thingy that I have to support. So things cannot be too packed. We need to be a little bit more conscious of space. But it's a crazy idea here with this card selector.
By playing entirely too much Balatro over the break, there's no real practical effect, just my video game addiction spilling out into my work. But oh yeah, so I can also project lists of cards.
Balatro, okay, I played Balatro. I don't find it addictive at all. it's just a card game, and actually quite exhausting mentally. So Balatro to me is more exhausting than programming. So yeah, I don't understand the fascination in this game.
Here, if I click on this list of cards, I get this, this whole little deck here, and it's got this fun hover and shadow effect. Just to kind of place, like I have this whole like layout.
Okay, I think there is one thing which may be breaking the effect here is probably the low FPS coming from the Zoom or whatever software is doing the desktop capture. It's probably doing like twice per second screenshot or something like that, and it's encoding that, so we don't see the animated version. Maybe you can find one online. Okay, we are not going to find it. It's probably somewhere on the dark web, on Twitter, unsearchable.
Kind of play semi-nicely together. Like it's like you can specify in my API different ways in which these UIs can be embedded. So like you see this like checkbox and slider here are just like inline, whereas like this text box thing and this card, they take up more than one line, but they behave a bit differently. Like this text box has a line break immediately after it, whereas the card, it creates a line break at the end of the line. So it secures more space for itself, but it doesn't immediately force a line break.
We've got a couple questions in the audience.
I think some of those things that Hazel does would be very natural in the HTML environment. So Hazel is doing its own thing, so it's handling its own rendering. But those things like those braced list of things with multiple heights, this feels like a solved problem in HTML. You know, you have blocks which can be aligned to the baseline.
Maybe Conrad, do you want to go first?
Yeah, I'm just wondering. I mean, you did these cards because you wrote the whole system. But if I were using your system, would it be a reasonable idea for me to implement something like your cards, or is it something?
Precisely, yes. And in fact, like our previous Livelets work defines like an API for this that, like in principle, will be implemented in Hazel. Like that's part of this project that I haven't gotten to yet. So like basically like each of these different kinds of literals will be implemented as kind of a small web app. Like we've got like a very kind of structured scaffolded way of implementing these small web apps. So like, you know, our idea in Hazel is like for whatever custom types you define, you can define one or more of these graphical literals in Hazel itself to better represent that data type.
Cool, and then we've got a question from John.
Yeah, when you toggle between different representations or projections, is there like a flat or like a text file in the background that has changes that save which one is toggled and which? So like if or is it all like just in the, you need to use the entire editor for the program?
So like right now, like I mean, I can copy paste these in the editor, and they'll copy paste as cards. If I paste them outside, they'll just paste in the text representation. The eventual plan is that we're going to have like a form of textual annotation that'll preserve that data when you go to and from the editor. But like, I don't know, we have like our lab has some disagreements over the level of generality we're aiming for with that. So I haven't implemented it yet. But yeah, the idea is that we do represent everything ultimately in a text serializable way.
This is going to be a real party. Gregor's got a question, and then I have a question. So let's keep going.
Great stuff, Andrew. I'm wondering, have you already thought about how keyword focus management should work between like jumping between like one rich representation, like the multi-line thing, and then going back to the other code, how that should translate these different layers?
So do you mean like purely if I want to switch between like these different?
More like when you're in a multi-line value and the cursor is in there and you want to keyboard out of there, how do you like?
I mean, so like that. that
Exactly.
is
Yeah.
that,
Is that something
answer your
that's
question?
modeled? Yeah. Is that part of your API
yeah,
that
yeah.
any sort of widget could
It's
jump out?
precisely that. It's precisely that. So like when I'm on the edge here, the parent editor is in control. But then yeah, like if a projector like this, it specifies the method that says that it can take focus, then when I press the left arrow key here, it has a method that decides, okay, I'm going to put the caret, inside at the end of the text area. And similarly, when I'm inside this thing and I press the right arrow key, it fires an action to the parent editor, an escape action, which hands off control to the parent editor again, and like also specifies the position at which the exit happens, so the parent editor can decide to put my caret back here. Like this is all accounted for in the API. Right now, I haven't really done vertical actions, so like this just takes me like that. But there's no reason I couldn't do that. I just haven't gotten to it yet. But yeah, I feel that stuff is very important, and it's like honestly, like getting the keyboard focus to work here and like the mouse focus was like a lot of work, but I've dealt with so many of these before that it doesn't, and it's always like a major pain point.
I realized you'd already answered my question. So, and the first time ever, maybe in the history of doing these demos, the audience time has been expired before the presenter time. So Andrew, the floor is yours.
One more thing with this card thing, as well as putting cards on expressions, I can put them on patterns. So this is like a pattern match statement here. So I can convert this, like this is a Queen of Diamonds pattern here, and I'm going to turn that into a card. I'm going to turn this into a card, or this into a hand rather, and this into a hand. So you see here, this is like, you might not be able to tell, but these are clubs. So this represents 5 unknown club cards. And this is jacks of an indeterminate suit, so 4 unknown jacks. And I'm going to put that evaluation probe on each of these things here, and I'll tell you what that means in a second. But basically, we're going to see which of these cases is evaluated. So like, I've got this hand up here, and we're pattern matching on this. And this hand, in fact, does begin with a Queen of Diamonds. So you see this is getting evaluated. And so you see a value here. This 1 indicates that this branch of the case is evaluated. These zeros indicate that these aren't evaluated. But if I change, oops, I can't, well, I just have to do these one by one, unfortunately. But yeah, if I change this Queen of Diamonds to an Ace of Spades, you see now it's a clubs flush. Now it matches 5 clubs. And similarly, I don't know if I have time to do it, but yeah, if I switched all of these to jacks, then I would activate this case down here. So it's kind of a fun addition to the framework. Ivan, how much time do I have?
You got about 2 minutes.
All right. I guess maybe just to step over briefly, I wanted to show you like this card thing was for fun, but like slightly more directionally where I want to go with this whole framework is like this live projector thing here is actually a pretty sophisticated system that I've just recently, in the last week, basically gotten working. So if I switch over to the probes slide here, as I kind of showed you before, I can put this value probe on something to see an inline evaluation. And if something is, I guess, as you saw already, like conditionally evaluated, I'm just going to use some keyboard shortcuts to save time here. Like here, this maybe evaluates to 21 here. So like this branch is activated. If I switch this toggle, that other branch is activated. But like, what if you want to have these probes in functions? So things that get evaluated more than one time. So I have this function here to convert to Celsius. Oh, I'm spelling Celsius wrong here. And if I put a probe on the function parameter here, I can see that this is evaluated twice. And that's because if I scroll down here, I see there's these 2 calls to Celsius, and I can put probes on them too. So you see, like, when I have this one selected here, you can see that this call to Celsius corresponds to this value of the input. And similarly, if I click on this one, you can see this corresponds to this value of the input. And scrolling down a bit to just some stuff I've already set up, I can see here, like, I mean, I have this Fibonacci function here, and I have these 4 calls to Fibonacci below.
And this looks nice. It's very interesting to me how this works behind the scenes, because I guess doing this would require you to like store the whole state of execution. If you imagine a function called like a computation-heavy program, I'm not sure how that would work then. But maybe this was solved, maybe this is the point.
So if I select on this call to fib with an argument of 4 here, I can scroll up and see that, okay, like when I call fib with 4, that creates this parameter value here, which activates this case here, which activates these 2 calls here. And these kind of grayed out numbers show like values in the recursive call. So I can kind of like step through here and like step through my computation, and these different decorations on these cells reflect like the full kind of recursive structure of intermediate values that get created. So like I'm kind of looking at this thing as like, I mean, A is just it's a super print line, like you see live values on the side, but then it also does these decorations to help contextualize these values within your computation. So if you put probes on multiple things, it kind of acts as this kind of like flexible scaffolding for.
So I imagine for each value there would be a stack trace recorded of like when it was like probed.
And like I said, again, this is a little bit closer to the direction I ultimately want to go with these projectors.
That's probably a great note to end on. This is amazing work, Andrew. It's so cool to see, and I'm sure we could go for much longer picking your brain about how all of this works and what you've learned over the.
So it would be cool to imagine what this system would be if you took it to the extreme. So if you came up with widgets for literally every construct in this environment, right? Then you would effectively transition smoothly from textual programming to graphical.
What, many, like 150 years of working on this now?
Yes. Well, thanks for having me.
Yeah, no, super cool. All right, last up, Christopher.
Cool, let me share my screen. And I share my screen.
If you have to relaunch Zoom or whatever, don't worry about it. We'll kill some time.
There should be a screen setting, right?
Sure. Sorry, what do you mean?
There we go. Okay,
yeah.
We're all good.
Cool.
Okay. Can you see?
Yes, we can.
All right. Am I good to go?
Yeah, you're all set.
Awesome. So this is a project called Folk Canvas that I'm working on with Orion Reed. It's really hot off the presses. This is probably the first public presentation about it. So I'll do my best to explain like what we're trying to explore. And so I'll start with an analogy, and then I have a lot of demos, and I'm probably going to go over. So yeah. So I'm going to start with the proclamation. Like no more fridges. And I'm trying to channel my inner Lou there. And so what I mean by that is like I feel like in spaces like this, there like a really common analogy that we use to like talk about like where computers should go is like we want to make computers feel more like a wood shop or a kitchen or a ceramic shop, right? Like these places, these like communal places where you have agency over your tools and data and things interrupt together. And that's like very startlingly different than the current like software topology that we live in, which is dominated by applications, right? So like one way I think about that is like our kitchens right now are just like filled with fridges, and they're big and clunky and sealed, and you can open one at a time. There's enough room to open one at a time, pull something out, put it in something else, right? Like copy and paste, right? And so we have hundreds of applications and browser tabs that are all just fridges filling up our kitchen. And it's sort of surprising that we could do anything in it, right? And so like, how do we, so what this project is sort of exploring is like, how do we invert that or subvert that model to a new software topology much closer to like how like actual like kitchens and wood shops feel. And there's a lot of people doing work on this. Like some people want to rebuild the operating system, tear down the kitchen, build it back up. Other people are more interested at like the data tool interop area. And it feels like no one's really exploring countertops, right? Like the spaces in which we're sort of we're laying down our tools and data exists and there's peripheral and you can manipulate things in space, right? So what this project is exploring, Orion has a whole video on it that I like highly recommend you watching, but it's really about how spatial canvases can become like our new digital countertops. And what we're more interested in is not building a new kitchen, but we actually think the web is pretty suitable for enabling a new like topology of software that sort of tears down like all these fridges and like opens up malleability, user agency, and stuff like that. So like one of the guiding questions that we're exploring is what would it look like if like spatial canvases were sort of like had primitives built into the web, and that's what we have here. So you can we've essentially
I will pause this here because I want to make some tea. We'll continue in a minute. Okay, let's resume.
First canvases were sort of like had primitives built into the web, and that's what we have here. So you can we've essentially like added extended the language of HTML with a new element that lets you manipulate things in space, right? And it works by itself, and you could rotate it. So it's a pretty common like whiteboarding stuff. One of the interesting things here is these shapes are like observable, just like other DOM elements. So you can sort of see here, you can add an event listener and actually like override behavior of this thing. So for example, this shape is locked on the y-axis. So the goal is to create and allow you to manipulate space in a way that feels like really native to the web. It's keyboard accessible, fully extendable, and stylable. You could shove arbitrary HTML into this thing, and you can also like responsively style it just with CSS. So yeah, again, the goal is to like make this feel as like native to HTML as possible. You can. Oh, hello.
Is this a library or an application or yeah?
So we're this is we're building a library like of primitives that are like trying to like push how far we can extend the browser, pretty much. So the goal is like eventually like this will be published to an artifactory where you can easily pull this into to any application or like any website, right? Again, no, we're like trying to like not create a new fridge, a new environment that like you have to bring everything into. We're trying to just create very like decoupled low-level primitives that can be like embeddable into any web page. So there's some more fun stuff. We can sort of start mapping like spatial properties to like variable fonts, right? Stuff like that. We can imbue web pages with physics. We can do more adversarial things, right? We have this like very simple primitive that lets us manipulate space. Can we inject it into like arbitrary websites and turn those into spatial canvases, right? Sort of like inverting the control that we usually usually don't see, right? So you can imagine like a Chrome extension lets you like take any website and start taking it apart and manipulating it, right? Right. So there's some really interesting explorations there that we're still doing. We can also augment. We could also have like infinite Euclidean space. Pretty common in like whiteboards. There's some like cool stuff that we can do around like semantic zoom. This is actually like just defined in CSS. So we can sort of like project qualities of the space through like CSS variables. And yeah, I feel like there's a lot of stuff around like maximizing like the like amount of the information density on the screen depending on like what's happening in the space that you're in, right? We can do things with like non-Euclidean space. So here's like a little like fisheye scrolling demo that I put together. We could also have things like radial space, right? So we're outside radial space. Now we're inside radial space, and we're always going to be pointing towards the center of that space, right? So you could like I wish I had like actual like 2D fisheye demo, but I don't have that finished at the moment. But you can imagine there's like all different ways that we might want to navigate like hypermedia and documents in ways that we like haven't really.
So I think it's not shown, but the idea here is that other web pages would be accessible. Like the idea here is to unlock the potential of the iframe, because there are a lot of capabilities in iframe of like manipulating other sites. I think this is the point here. It could be like a very, very nice way to access internet, to kind of create mashups.
I haven't really been explored before. There's
There's a
things-
question from John.
Yes.
So this is really cool. And one of the things that kind of brings up in my mind is like, are you thinking about like how much is too much? Is there ever like, oh, if like, will this just break if it's, too complex of an interaction that is trying to interact with other elements that may be doing something else? Do you have any thoughts on what if there should be limits on how crazy things you can do?
I this project's a little too early on to like know. I think we're really trying to push that as far as possible, and there's going to be so like I talked about like can we bring the spatial canvas into like documents that were never designed, right? Like there's places that's not going to work. So like traditionally Google Docs is written in like HTML canvas. It's not DOM elements. We can't tear that isn't malleable. That isn't like malleable in the way that this project is exploring there, and there isn't anyone that can really like do anything about that, right? And that like sort of goes back to like the leading analogy, like there's like economic and technical reasons that that a company might want to like trap that in, right? So we want to push it as far as we can, but there's surely limits to what we can do. And also traditionally like modern JavaScript frameworks, they want control of everything, and if you start messing around with things, right, like things could break. But we really want to like see how far we can push that. I think Andrew has a question.
Yeah, in fact, what you literally just said was the perfect lead-in, so thank you for that. So yeah, I absolutely love this. Like, I feel often when I do web stuff, which is all the time, I'm like, I don't know, fighting with the DOM. Like, I've re-implemented all of these rich primitives. I want them to exist. I want to use them in the world, and I see this, and I love this. But I'm also like super pure functional programming pilled, and I mean, I spend basically all my time in like declarative frameworks,
right.
Similar to React. And like, to some degree, maybe I'm fighting the web by doing so, but like, I'm wondering whether there's a story here. Like this seems like from the console inspector to be highly stateful. And I'm wondering like both in practice and in theory, how you would see this potentially interacting with more declarative approaches.
Yeah, a couple thoughts there. Like this is object-oriented programming, right? Like we're geometrically encapsulating like, state of the shapes that we're manipulating and stuff. The web gets around that, right? Like HTML elements work by themselves, right? Like if you put an input onto a page, it works by itself, and it has there's multiple ways you can override that behavior, right? So that it can work in a more controlled sense. So that's like sort of how we've been designing Shape, for example, right? Like it works by itself. You can like put this into adversarial environments. You can also like fully control it yourself if you don't want it to do the thing that you want, right? And that's how like some of these demos work, where you have collision or whatever you want to say. Hey, actually don't move me. Let me tell you where to go. So that's how the web gets around that, right? It works the same way as HTML inputs, where you're listening to events and binding data down in like a declarative fashion. So we haven't really tested in frameworks yet, but conceptually you would be able to take this custom element, put it into React or whatever declarative templating system you're using. Yeah, so that would be the goal.
There is always some friction though, like trying to fit something which is not something that's fundamentally stateful into a functional model. It's always going to work because like functional model can represent that, but it's not going to be very efficient because you will have to recompute a lot of stuff. Like try to find like diff for updates, all sorts of hacks you have to do to make it work, and even then it's still not working as nicely as a native approach.
Goal. If there's
There's
no more questions,
another question from Jasmine.
Jasmine, cool.
Yeah, thank you for the demo. I'm really hyped to. This is all my frustrations with P5.js addressed, which is, you know, a game engine in the browser that can't do spreadsheets. So force back to D3, which doesn't, which is just sugar. So I'm definitely dreaming make little bespoke explorables for all the thing. It reminds I've been feeling out game poems as kind of the closest approximation to explorables outside of kind of that teaching model. And I like the game jam culture. When do you think full shapes will be ready for like game jam type events?
I don't have a good answer on that. Like the stuff we're working on is open source. It's not published yet because it's not ready. There's still a lot of explorations and polish that we need. Things are what we really want is we want to nail some of these lower level primitives. I've only showed you one. There's a lot more. But hopefully within this year, maybe summer, we can start like sharing this more widely, seeing letting people use it once it's ready. But yeah, there's a lot of similarities of like game engine-esque kind of feel, but in like a way more webby way, right?
Heck yeah.
Which is good and bad. So yeah, hopefully that answers your question. Anyway, we can observe space and project it and morph it into different things, and I think we're like lacking some other compelling demos here, but this is just one with like spreadsheets, so you can conceptually manipulate things. What happens if you bind other things? You can start defining relationships between space, right? In this kind of projection. So that's like space related things that we've done. We've also like one of the core concepts is like how do we define relationships between different parts of hypermedia. So this is an HTML arrow. Right here, you can like declaratively specify source target with like CSS selectors. You can also like imperatively just set DOM references on this arrow, and you have sticky arrows. There's all different types of layouts that we want to explore. A fun one is rope. Another one is Yanadu links. For all those tools for thoughts people. This is the same demo, but it's actually Yanadu links between iframes, so we can start defining connection in like an adversarial sense on like websites that we don't own. Let's see if I can show that.
So he's referring to adversarial interoperability, which is like hooking into other apps and making them work nicely with others.
We have two iframes and a Yanadu link. And what's driving this is again, like some kind of web extension that would inject a script in. And there's some like post message protocol that like lets you observe bounding box changes to elements in websites that you don't own. So that's like another like adversarial exploration here. Binary connection isn't the only type of relationship that we have. We also have like set relationships. And so here's the convex hull. This stuff works both on like our shape, right? Like, and also just regular DOM elements. So you can sort of see here, this is just a heading and that's part of the space too. And we can observe those changes. A fun type of set is distance fields. And there's some really interesting semantics around, merging, like proximal merging that we're like really interested to play around with. We can also do sand simulations with building off this like set primitive. In fact, we can do sand it's sort of hidden here, but we can do sand simulations across iframes. Again, building on these primitives. And it also works with, it also works with just regular p tag or input or whatever. So that, the next question is we can define relationships. Can we imbue those relationships with computation? So what you see here is Orion's work on what he called scope propagators. We're not calling event propagators. And essentially what they are is you can define a binary connection between things. When an event happens, we're going to perform some code. So here we're just adding exclamation marks. Here we're binding X in rotation or Y in rotation values. We chose rope because it's alive and it's fun.
So one super cool thing that they are doing is that they are not mentioning this explicitly, but they are taking a lot of fun stuff that they kind of created over the years, and they are putting them together in a single environment and showing them how they synergize together. And this is cool. I think in programming, especially in hobby projects, this is the superpower of hobby projects that are developed over a long time, is that if you don't develop them as separate, tiny projects, totally separate from each other, if you try to mash them together into a single mega project, they tend to eventually produce those nice, very nice, unique, they get very nice, unique capabilities.
Fun. And there's also a lot of semantics just waiting to be found. So
So here are those propagator networks. There was the sun simulation. There were ropes, connection ropes, connections as arrows. I wouldn't be surprised if a couple of slides below we will see some language model kind of interacting with HTML. That's my prediction. Let's see.
When there's syntax errors, let's break the rope and mend it back together when there isn't. And you can have tools where you can chop the rope, right, and it breaks things, and you can mend it back together, and it should work, right? So there's a lot of semantics around more physical, physics-based connections that I think is really waiting to be explored here. You can start creating little interfaces. Yep.
Can I get a clarification in it? So, am I understanding that the state authority is the web document and the nodes, and then we're adding these kind of constraints over the top, which presumably has to be JavaScript, and is there any issues with constraints fighting and things like that?
Yeah, definitely. These propagators are little constraint engines. They can be operated used in that way, but it's not going to be something. It's a last right win kind of scenario, right? If you have competing relationships, if that was sort of what you were asking.
Yeah. And also, I just want to confirm, the node, the DOM nodes, they are the state of the system. There's not too much in the script.
Yep.
Yeah.
So that's, you can sort of see that here, right? We can color QR code, type it in. So you can see with a couple HTML elements and a little bit of rope, we can start building small user interfaces. This is just a crossfader little effect that I did. It works, but I don't think I can share music. What's more interesting is, can we take something like a map, project it into a spreadsheet with these event propagators, and then project it out, right? So in the ethos of tearing down fridges, spreadsheets are typically an application. Can we start embedding them and imbuing them with computation from the outside? So that's sort of what this is exploring. So you could sort of hear we're just doing some derivation that's changing the coordinates. And
we're about out of time, so I'll get you to do a 30-second wrap up.
Okay. Direct connection isn't the only thing that way we can imbue in computation. We can use proximity. So I could pan around this map, and these things are connected. So you can start. That's another form of way we can imbue things with computation. these different models work together. So I could pan around. I could also use event propagators to pan around. So we're really interested in like composing, like how do we compose rich media and all different types of programming models together. That's like something that we don't usually explore, because like something you see a lot in this community is like people are like incentivized to write applications and websites, and there's no composability between them.
So what they are exploring is multi-paradigm approach. There are some languages, some technologies which call themselves multi-paradigm, and pretty much always when one appears, they're quite successful. Like C++, this is one example. It's a programming language that attempted to be a multi-paradigm, to combine object-oriented and procedural, like C-like programming models, and it works. And it also has functional, you can also do functional style programming in C++, mostly. Yeah. In terms of user interfaces are always very rigid. They also have some kind of paradigm, like usually those are forms, like buttons and forms. And we also have web. Web is slightly different. We have node and wire environments, and they can work together. Yeah, absolutely. This is what Automat tries to do as well, to be this environment where different modalities, different user interface approaches kind of collide.
There's no ways we can like take two different projects and like see how they work together. So again, that's why we're sort of looking into like, what does that countertop look like? How can we start taking these separate things and seeing how they like feel together? There's also tools that I won't talk about. Orion made this like really fun like weak layout tool.
Hey, this is cool.
That's pretty much it.
Very tantalizing.
Yeah, we're still really
okay. That was shown for a couple of seconds, but it's a very nice idea. And this auto layout, where you can add new objects between others.
That I won't talk about. Orion made this like really fun like weak layout tool, and I will stop. That's pretty much it.
Very tantalizing.
Yeah, we're still really early on.
Please, yeah, please continue to post demos of this kind of stuff in the Slack, because it's all very visually enticing and fun to see, and will be good to see how this project evolves as,
Thank you.
As you keep exploring.
Appreciate it.
Yeah. Sorry for the very loud grinding noise if that's coming through on Zoom at all. Thank you to our three presenters.
Yeah, okay, that was everything. So, that was an interesting interlude. Now we can get back to our assembler. Okay, buttons. We want to display labels. So we have a filter function. Filter function is a mutating function that clears the instruction set and repopulates it based on the filters. I think okay, those are our filters. I'm wondering how to do this effectively. I think one way to do this would be to show those numbers here. When we draw the table, after we draw the icons, to filter, so for each register, and then we would draw the instruction count. The thing is, this filtering, I'm not sure how expensive this is. And we are not really interested in the whole instruction set, so we don't really need to allocate an instruction array. But we would need something like that. Okay, and actually there is a bit of code here. So when we go through this, I want to avoid memory allocations during counting. That would be terrible. Here we are just working on pointers. And this builder, I think it's just a very tiny wrapper, yeah, around inst and inst. It has small vector, so it doesn't allocate anything. I think we could what kind of things do we use here? Inst info, instructions, and visited. I could turn this into a static function that could be reused. Because this block of code I want to reuse, it's going to get more complex soon. So in the new version, this visited will not happen at the start. It will happen at the end. Maybe it can happen at the start. we are not going to have that. There is... Okay, so instead of trying to create a separate function, I will copy paste because I think we'll have a couple very similar variants. So here okay. So here I have a version of the filter function that doesn't actually do any filtering, that takes an existing instruction library we need this visited. And the point here is to increase the counter. There should be a way to validate an instruction. Nope. Okay, I think if we get to the end, we can just increase the counter. It's called counter.
Low pass effect.
Okay, and this is general purpose register count. It's probably fine. I'm thinking whether maybe there is a better structure for this code, because I really don't want to repeat this part. We don't have that many instructions right now. Okay, let's go back to our draw function. Is everything expanded again? Actually, yes, this is something we could cache within the widget, so we don't need to be super careful about performance. I'm so happy I have a nicely designed API for this, because that would be awful. Okay, so here we have a copy of the state of the filter of the instruction library. Yeah, actually that means we don't really need to do this efficient thing. We don't care about efficiency, because we can cache this properly. Okay, we initialize this to 0. Okay, let's get the font. I think we want to draw in black here. Sorry, not black, blue, like an ink. I want to grab this color. Okay, those are all zeros, but we didn't populate this table correctly, and we still have to translate to the proper position. Actually, there could be a better way to measure the width maybe not of numbered text. Anyway. Okay, in the y coordinate we should do minus cell size. Let's try to align this in the middle of the cell. Okay. So horizontal alignment should be all right. It is perfect. Now the vertical. I think we should subtract half of the height of the text. Unfortunately, I don't keep this around, but we can do that. Cool. We have nice numbers in the table. Let's also print the ones in the row below, and then we will update them. I think aligning text in table is easier in C++ than in JavaScript. And this is how you do like vertical and horizontal alignment, and it's pretty much perfect. It's crazy that something so simple is so hard in CSS, and the math to do it is just subtract a couple numbers. Okay, now whenever we select a new category, we should repopulate those values.
CP Chica says,
What are you using for rendering?
This is... so the window uses Vulkan context, and the library that does the drawing is called Skia. This one. You may be familiar with this because it's used all over the place. It's used by Chrome, Android, to name the few. And it's open source. It can translate, the drawing commands that we are issuing into efficient Vulkan calls. So that's nice. So I can just tell it to, hey, render some text for me. Stop moving. I need to change this behavior.
And it's hard to build from source.
Oh yeah. That one isn't particularly kind of fun to work with. I think they don't use CMake, or I'm not sure actually. I think they are thinking about switching to CMake, or maybe they gave up on this already. Anyway. Yeah, you are absolutely right. It's a pain to build. Once you get this to work, their build system, it's actually a little bit more convenient than CMake, honestly. CMake is it feels like a piece of software from a different age.
Google is doing proprietary code through obscurity.
Yeah, I'm pretty sure it's not deliberate. An easy thing to do is to use some wrapper around Skia. There is React Native. There's like a framework for writing apps in, I don't know, TypeScript maybe? I don't know. No idea. Or there could be more, like Skia wrappers. Skia Sharp, yeah, if you're using C#. Or you can just go the easy way and use the JavaScript canvas. Because JavaScript canvas, behind the scenes, it's just using Skia. Literally the commands that JavaScript canvas has, they are almost one-to-one translation into Skia commands.
I like poking at memory manually.
Yeah. Okay, so if you're into that stuff, then building Skia should not be a problem for you. Just do it. I know it feels like it's going to be a pain, but in the end, you just follow instruction. There could be some weird issues related to flags on Windows in particular. If you want, you can take a look at in Automat source code. There is skia.py, and there are some flags which are useful to know about, because sometimes not setting them will just prevent it from working. So yeah, so maybe this kind of stuff it could be in the documentation, or this in particular. This was the worst. ABI. So Skia uses different ABI in release and in debug mode, which is such a pain. Once you pin them down, it just works. Okay, so here we do library filter. But actually, what I will do, the plan here is to go over every possible filter, toggle it, count how many right to okay. And I actually want to try something new. I will code with O3 Mini. I tried it yesterday and it worked surprisingly well. By surprisingly well, I mean that it didn't mess up my code. So I am going to try it now. Here. Let's call this update filter counters, blah blah blah. Okay, let's open a new chat. Let's give it access to this file. Let's give it access to the header. Yes. Can I add this to the context? Nope. Actually, this is going to be super simple, but let's see if GPT is useful for anything. It's actually perfect because it's a super simple example. Okay. This is taking longer than it would take to actually do it. Nice. Oh, it's using backups. I would do it by like retoggling everything again at the end. So it's copying those arrays. Actually, instead of saving the original state, let's just do it like that. So we're applying the filter, we are recording the size. And finally, we're doing the proper filtering. Cool. And I'm okay with this being kind of slower, because it's only going to be called when we press the category button. So it's not going to be invoked on every frame. Cool. And now we see how many instructions we have in the deck, depending on the category that we select. For example, there are 4 increment instructions. You can see them here. Those registers, though, we should use them for filtering. So let's do this now. Add opcode. This we can skip, we don't need it. Okay, so the plan is we have an array with a bunch of filters. So whenever there is true in this table, we should try to find an operand within the instruction builder that we can flip to on. Essentially, yeah. So then all of the remaining operands we will fill with some default values, like immediate, 0, condition, default. And then we will produce an instruction. However, if we cannot find an unused operand that we could populate with some specific register that was enabled, and then we will just skip the current instruction and continue. This is going to be tiny. I think there are maximum 6 operands for every instruction. Oh, let's do this with a for loop. if the given operand was already filled, then we will skip it. Actually, no. This is a bit of a problem because we have to add them in order. So we have to flip the iteration. Iteration. We have to flip this sequence. So instead of used operands, do we even use num operands anywhere? We don't. Can I do this? That would be nice if std array could be initialized from a regular array. Okay. Short break. I'll be right back. I need a different name here. Actually, it would be nicer if we had something even different. Okay, different idea. I will not store this as an array of booleans, but as a regular vector. Because this is how LLVM represents registers, as just unsigned integer. I think vector is nice because I think the order in which I click the buttons could be used. Oh yeah, and we need a std vector, of course. Okay, in this general purpose register count, we need this. But it's redundant with those registers. Okay, and those arrays will stay the same. We cannot do this. Removing stuff from vectors is a pain. Okay, I think this is it. This is the right way to do it. Yeah, terrible code. Cool. Now I have to do the same here. Not quite. Yeah, I need this erase. Vector should have a better functions for removing elements, really. Okay, I think now we should go through those implicit defs and uses. And take care of those. Actually, no. It should be the opposite. We are iterating over all of the defs, all of the register that the instruction fills. So we should remove a register from the write to queue. And now this is actually unsigned short, so even nicer. So I need to convert LVM EPAM, which is in the def, to move the registers array up. Okay, so if the register used by the given instruction is super register, then we should remove this from the list. I shouldn't use I. Oh, I'm using I at a global scope. So this contains one of my register indices. Okay. We need basically the same thing, so I will just use code completion. So the reason for that is that when you select that you want to read from some register and an instruction actually uses this register implicitly, even though it's not a concrete argument, we want to clear it from the queue. Okay, so next we are filling the register arguments, and by default here I am selecting register 0. So if okay, and our queue, we actually need to use a queue here. I think I made a mistake here because I'm just pushing back the register. This is wrong. I should pick better collection types. This kind of flipping is hard. Okay, it shouldn't crash, but still not all we need, because so we are removing them from the queues. But the thing is, if any of the queues still has values at the end, yeah, then we return early. Okay. Let's try debugging. Actually, this condition should be the opposite. Check this out. For tests, we see there is a difference. For example, if we say that we want to read RBX, there are apparently some tests that will never read it. Strange. So this is SBB means that we will use the borrow flag. Seems like we have a mistake here somewhere. I think we filtered to 0 instructions. This is probably why it crashed. Probably have a piece of code that assumes we have some instructions always. Yeah, this MISC is interesting. Yeah, random instructions like rdrand. There are only versions which write to some registers. Yeah, and the time, similarly, there are only versions which only write to some registers. Okay, I think, I'm not sure if I can finish this today, but let's try implementing the button handlers so that I can click this selection and we can select the registers to read or write. Maybe I should commit the stuff that I've done so far. Okay, so we need this table size. It looks like this is constexp. Oh no, it's not constexp because we cannot have constexp square root. Do we want this? I think we do. I think I remember. It was... something like that. Okay, so this is our sqrt function. Can even put this in line. Or not. I think it confuses the compiler too much. Nice. Is it still working? Yep, seems like it is. Amazing. We moved. I mean, it's not much math, but we moved everything to const exp. This is how most of C++ should work. Because none of those values should really be computed at runtime. Okay. Now that we have done that, we can move those constants out. And I can use them here. I'm removing the left column. Doing this. Okay, so the column tells me what register we clicked, and the row tells me whether this is read or write. on this. Okay, this is the correct implementation. Nice. We're still not displaying which register is selected. We should do that. Okay, so let's try moving to fitsmid DI. Something's not right. It's like this shouldn't be the second argument here. So the instruction says and do those knots. And this is not changing anything. I think maybe I messed up the Q selection in the in the filter function. So this is time for printf debugging. What? Select random. Okay, let's just deselect this category, or like select this. Okay, we are initially okay. No, so this is because we are calling filter with register 0, then calling it again with register 1 up to 5. And then we are repeating the same for write to. Let's say I want to read from DI. Five zero, 5-1, 5-2, yep. 5-3, 5-4. And then nothing, because this is toggled off. Okay, maybe I will print easier to see now. Okay. Something's wrong because, and it has to be here, because we are setting this filter properly. And now it's time for proper debugging. So I will put a breakpoint here, but I will disable it. It's so slow to launch. What's happening? So now I want to enable this breakpoint, and I'm hitting, okay, maybe not yet. So first I will select a category, like decrement, and let's say I want decrement DI. So I want to write to this queue. Let's go in. Okay, so this is the opcode that we are adding. Operands. It has two operands apparently. Decrementation. Okay. So we are going through implicit defs. Those are writes. So register 28. So this is the eFlags register. It's fine. Okay, now we use this. And there are no implicit uses, okay. So our read from queue still has one element, and we are going through operands now. So the first operand has type register. So this is operand number 0, so we should take write to queue here. Cool. Okay, and the queue is empty. So we are writing to AX. That's fine. That's good. I see. Okay. So some operands are tied to others. And I think this is the case for the decrement instruction. So the second operand is tied to the first one. I remember how LVM works. So many ways to do this. We just have to pick the best one. Like the most direct way. Yeah, so when I am selecting the first operand, I don't know that it is tied to something. think I can do this because the builder is actually very simple. It contains mcinst inside. So when I do this cast, I get the reference to the actual mcinst, no allocations. It's really nicely designed, I have to say. Can do that. Oh yeah, and we should also do okay, this is weird because so when di is the source index, the first argument should be set to 0, which is the AX register, and the second should be set to this tied operand. So read from Q should have some non-zero size at the end. Let's restart. Or maybe not restart. That was pretty strange. Okay, now it actually looks reasonable. And the weird thing is that when I actually enable this filter, it's like looks like I broke something. So it might be possible that when we get this constraint, the index could be higher. There is some bug, some memory issue, because it's filtering differently now. Okay, for instance, let's try to filter only for instructions that write to dx. So the first opcode. Okay, read from Q has size 1. This is just the dx, index 3, correct. There are no implicit defs. I mean, no, there is E flags. There are no implicit uses. Okay. First operand. Okay. Our Q is the right Q. Nice. This should not be tied to anything. The Q is empty. Yep. So we should fill this with EAX. Nice. Now the second operand, this is the register that we are reading, which should have a constraint. Now we are selecting our read queue. It has a constraint, it is tied to index 0. So we are grabbing the tied operand. Okay, we are setting this to 3. Or maybe it's alright. Register 3 is AX. Okay, I guess this is the default. It's okay, this is probably fine. So where were we? So reg LVM is 3. We are filling it. Cool, and that was it. Now, our read from queue is not empty, so we should return. Nice. Okay, this is strange because yeah, this instructions is now set to 0. Okay, there must be an issue if our crazy filtering logic. This is the only option. This must be broken. Yeah, we have to initialize them to 0. That was annoying. This is strange. It's like there is no difference between clicking this and this. Yep. Okay, I think we also need to update the cards after this filtering. Okay, so when I click a category, it does the animation. But when I click this, it doesn't. Yeah, it's because the registers. I'm only comparing opcodes. Yep, I will just do small copying here, and that should fix it. So I can select which register I want to access. It's not perfect because this should follow the size. This is something I need to change in the filter function again. Okay, so I need to find a register which belongs to this register class and is sub-register of this one. So this is our super register. I can iterate over subregisters. Get matching super register. Nice. It's not so simple. We could construct some mappings, but really I can just do the for loop. should be the opposite. And also here. And also here. What? Ink SSPD? Okay, some weird instruction. Increment shadow stack pointer. I will ignore this. I am going to leave a to-do to fix this. All of the decrementations, AL, AX, EAX, RAX, and I can say, hey, I want to change B, X, and it fixes itself. I wonder, oh yeah, I also have to check for equality. Yeah. Cool, I can select register types. I don't know why it sometimes rotates the cards. Try to subtract, for example, let's say I want to write to CX minus BX. Yeah, works. We have quite a lot of instructions because each of them has 4 variants, depending on the size of the register, and there are 2 of them, one which uses carry and one which doesn't. Cool. Cool. So this is register filtering. I think this is enough for today. We didn't implement everything I wanted. So grabbing the cards from the stack isn't yet working, but yeah. We're not that far. I guess I should record a devlog. Maybe I will do this on Monday. Yeah, I feel Monday is a better day for a devlog. So what have we done this week? To summarize, I think on Monday we created the scrolling animation, if I remember correctly. On Wednesday we went through all of the assembly instructions that LLVM supports and we selected the ones which make sense here. So now we have nice categories for instructions, for example bit flips. Say I want to write to DX. And those are all instructions that will flip bits inside the DX. Quite a lot of bit twiddling. And we also have jumps. Yeah, we can select the jumps which will read the CX register, and there are 2 of those. This jump equals CX0, or maybe ECX, jump ECX0, and this is jump RCX0. Cool. Yeah, this is exactly as planned. regarding those jumps, I think we could create a similar widget for conditions, because there are lots of conditions that we might want to filter for. This seam of GR8, we have to get rid of this. I think it would also be nice if we maintained position when switching. For instance, if I'm in ends and I select the end category, we shouldn't really reshuffle the deck. We're still so far from finished. We also need to have some indicators when the button is selected. And also hover indicators that, hey, you can click this. A lot of work. Oh well, we will get to this on Monday. Or maybe I will try to do something over the weekend, we'll see. Anyway, this is it for today. See you next time. Bye.